Hi, it's Kevin Lebates here, and I thought today I would talk about one of the most fascinating things about human beings, which is that they are able to think about and debate and develop things in an abstract sense before it's possible to build them physically. And the classic example of this is the computer. You had mathematicians and logicians talking about the mathematics of computer science before there were any real computers available to actually build the things that would then do what they were talking about. And the academic literature is full of stuff from people like Turing and Church and Russell and others like that, where they are exploring the concept of computers. Oh, sorry, I should mention von Neumann there as well, of course. Where they're exploring the concept of computers in an abstract sense. The ideas are being discussed, but there's not anything in the physical world that they can use to build such devices. And then decades later, they become a reality. They get built and they get improved, and architectures are designed, and suddenly we have these devices and then we just take them for granted. And I've hit exactly the same thing looking at the theory behind quantum computing. Now, I'm way off from being any kind of expert on the mathematics of quantum computing. It's in a particular area of mathematics that as an undergraduate I wasn't particularly great at and kind of dropped as soon as I could, but I'm now revisiting it because now I have something that I can tie those concepts to. And when you look at quantum computing and the mathematics behind it, it's interesting to see that the algorithms that are going to be used to crack asymmetric key cryptography, for example, things like RSA and ECDSA, were actually come up with decades before there were any physical quantum computers available. And now we have people actually building devices. You've probably seen the pictures at the front of various articles, all these weird gold-coloured cylinders dangling from the ceiling like something out of a science fiction novel. But the basic concepts that they're going to be using are ones that were discussed decades earlier, when there were no such devices around to then test them out with. And yet they work. And that is one of the most fascinating aspects of mathematics, I think, is that people can reason about stuff and logically deduce stuff and engage in debates about stuff that doesn't exist, and then years, decades, or sometimes even centuries later, we can actually go and do it in the physical world, and most of the time it actually seems to work. Anyway, I'm going to wrap this post up now because we don't want it to get too long, but it's just a little observation about how the world works, and one that I think is particularly exciting. But then again, I'm a mathematician, so I would think that. That's it for today. See you in the next video soon. Bye for now.